The model had demand. Then capacity ran out. Moonshot paused new Kimi K3 subscriptions after demand pressed near its available capacity. The useful question is no longer who can design a chip. It is whether an entire machine room can be supplied, linked, cooled, and kept working. A model can impress on a benchmark yet still disappoint when the waiting line arrives. That changes the race from a chip contest into an output contest. A capacity pause can reveal more than a product launch ever does. A subscription pause is a business receipt. Users arrived faster than the serving stack could absorb them. That does not prove one missing part caused it. It does show that model demand becomes physical demand very quickly. Think of an AI service like a restaurant at dinner rush. A better menu helps, but it cannot seat more guests without tables, kitchens, deliveries, and staff. Every answer has to travel through that chain before it reaches a phone or browser. Compute capacity has the same awkward dependency chain. The next surprise is where the controls reach. The December controls named 24 kinds of chip-making equipment, 3 kinds of software tools, and high-bandwidth memory. That is a supply chain map, not a single product ban. NVIDIA describes the relevant limits through processing, density, interconnect, and memory bandwidth. Read that list carefully. It reaches into how chips talk, not only how fast one chip calculates. A weaker part can still become a serious system. Huawei's cluster approach is straightforward. Use more chips, then make the architecture coordinate them better. That shifts the contest from peak chip strength toward the quality of the whole machine. Huawei calls a superPOD one logical machine built from many physical machines. The strategic idea is clear. Hide the seams from the workload. The engineering cost is also clear. Every seam still needs reliable hardware and software. This is the turn. Adding chips can soften a chip deficit. It can also multiply demand for memory, packages, network links, power, and debugging. More pieces create more chances for delays, failed handoffs, and idle hardware. The workaround creates a larger factory problem. 4 production gates decide whether that workaround scales. First, memory. High bandwidth memory sits beside the accelerator because AI work needs data close and fast. A compute chip without enough nearby memory is like a kitchen with no ingredients at the stove. Second, advanced packaging. Chips and memory must become one usable assembly. A design win is only a drawing until packaging turns separate pieces into a working module. Third, networking. Large models spread work across many devices. Slow or unstable links make expensive accelerators wait. In a cluster, waiting hardware is output that never reaches the customer. Fourth, software stability. A large system needs tools that schedule work, recover from failures, and use the machines efficiently. Hardware volume without dependable software is a warehouse, not capacity. Domestic substitution can move the boundary. It cannot erase the chain. Huawei's roadmap says the Ascend 95DT is due in the 4th quarter of 2026. Roadmaps matter because they turn replacement from a slogan into a schedule. Yet, a scheduled chip still needs every surrounding layer to arrive with it. Domestic alternatives can reduce dependence at individual links. The harder task is synchronizing all the links at production scale. That is why output, not merely chip design, is the bottleneck investors should watch. That is the answer to the Kimi pause. The leverage sits with whoever can deliver a dependable full system repeatedly. For the memory side of this story, watch the channel's documentary on MU,